We will be looking at summing an arithmetic series during this video. Okay, in this example, what I'm going to try and do now is add the first 50 terms of a series together. So what I'm going to do is to try and pair the numbers up. So for example, the first term with the last term, the second term with the second last term, and so on, and try and hopefully that will form a pattern. So if I look at the last term and the first term and add them together, it's going to add to 51. If I look at the second last term and the second term, 49 plus 2, it's 51. And if I look at the third last and the third term, again, that's going to add to 51. So for the sum of 50 of this, it's going to equal, I'm going to halve the number of terms because we're pairing them up. So 50 over 2. Then I've got my first term, 1 plus my last term, which is 50. So if I simplify that, 25 multiplied by 51, then that's going to give us 1,275. So now if I'm coming up for sum of the nth number of terms, okay, it's the number of terms over 2, first term plus the last term. What I can also do there is think of L as being the last term, okay, and we've looked at finding the nth term before. It is a plus n minus 1 times the difference. So what I can do is now put this in place of L because this would be the last term of our series. So now the sum of n is going to equal n over 2, a. Now instead of L, I'm putting a plus n minus 1 times d. And if I simplify that, I get 2a plus n minus 1 d. So I can use either formula to find the sum of an arithmetic series. So now, what is the sum of the following series? So it's all the numbers from 1 to 100. So looking at our formula that we just looked at, number of terms over 2, first term plus last term. So the sum of the first 100 terms, number of terms is 100 over 2. 100 is the last term, so I'll put 1 in first. First term is 1 plus 100, so that's 50 multiplied by 101. So the answer is 5,050. So in our example here, in an arithmetic series, the fourth term is 6, and the sum of the first 16 terms is 120. Find the common difference. So what I want you to do is to pause the video now and have a go at this problem yourself. Okay, so what I'm going to do to solve this is write down the information that I have. It tells me the fourth term is 6, so term 4 is equal to 6. And if I was thinking of our formula, so Tn equals a plus n minus 1 d. Okay, so T4 is equal to a plus 4 minus 1 d. So that will simplify down to a plus 3d is equal to 6. And then the sum of the first 16 terms is 120. Okay, so sum of 16 is equal to 120. And I'm going to use the formula that I've looked at just previously. So that's 120 equals 16 over 2, 2a plus n minus 1, where our n is going to be 16, d And simplifying that, 120 equals 8, 2a plus 15d. Now I can get rid of that 8 by dividing both sides by 8. And that'll give me 15 equals 2a plus 15d. All right, so now I end up with two equations. So 6 equals a plus 3d, and 15 equals 2a plus 15d. So what I'm going to try and do is solve them simultaneously, but I'm going to multiply this equation by 2 so that I can eliminate a. So times the whole equation by 2, that'll give me 12 equals 2a plus 6d. I'll call that equation 2, this equation 1, and I'm going to subtract equation 2 from equation 1. So we have 12 equals 2a plus 6d. Subtracting that, 15 minus 12 is 3. That'll equal 0. 15d minus 6d will equal 9d. So finally, divide both sides by 9. And therefore, d is going to equal 1 over 3. So we have found our solution to find the common difference, okay, which is 1 over 3.